Hey guys, we're starting with 9.2. 9.2 is exponential functions, as we talked about yesterday, graphing exponential functions, equations with x and y interchanged, applications of exponential functions. What the heck is e? We defined this yesterday, and here are some examples of exponential functions. Do not forget that the a value, which is the base of the exponent, is always positive and it is not equal to 1. That is the definition of an exponential function. Yesterday we left off here graphing 10 to the x. We didn't graph it because we did graph 6 to the x in class. But as you see, if I graph 10 to the x, then I'm going to plug in different x values for my exponent. If your x value is in the exponent, it's an exponential function. So I plug in x values and I get the y values out. For example, if I plug in 0 for x, I get 10 to the 0, which is equal to 1. If I plug in 1 for x, I get 10 to the first, which equals 10. And I continue doing so until I can graph the entire exponential function, which is here in orange. The next question is saying, find the graph of 1 over 10 to the x. So we notice that now my base for the pink graph is going to be the reciprocal of the orange graph. So the bases are the reciprocals of each other. I had 10 as the base in the orange. Now I have 1 over 10 as the base for the pink graph with my x as the exponent. I notice when I graph this that this is going to be exactly the reflection of the orange graph, and it's going to be reflected over the y-axis. Because this graph isn't shifted at all in the left or the right direction, the y-axis is going to be that axis of symmetry where these graphs are reflected. If I had shifted my graph left or right at all, then it would be reflected over a different vertical line, but because the bases are reciprocals, they are going to be the same except different, reflected differently. If my base is smaller than 0, I'm always going to have a decreasing graph. The reason is because if your base is smaller than 0, and you take multiples of it, which is what you're doing when you have an exponential function, you're multiplying the base by itself. The more you multiply the base by itself, the smaller and smaller and smaller the y value will be. So that is why if the base is between 0 and 1, if the base is between 0 and 1, the graph will be decreasing. As you see in the pink graph, I am decreasing down as I go left to right. If my base is bigger than 1, then I will see that my graph will be increasing. The reason being because as you multiply a number bigger than 1 over and over by itself, that number is going to get bigger and bigger and bigger and bigger. So if my base is bigger than 1, the graph is increasing. If my base is between 0 and 1, then the graph will be decreasing. Moving on to example 3, here is the graph of 2 to the x. 2 to the x is graphed very similar. It's this really faint one right here. So that's the graph of 2 to the x. What we wanted to do here is we wanted to explore what happens when you add or subtract a value to the exponent. Because the exponent is the x value, when you add something to the exponent or you subtract something from the exponent, it will be shifting it along the x-axis, which means shifting it left and right. Okay, so if I have a plus 2 with my x in the exponent, nothing makes sense with your x. It's always the opposite. So if it's x plus 2, this graph should be shifted to the left 2 units. So if I look at my original graph, it's this faint black line, okay, or black curve. And then I graph 2 to the exponent x plus 2. It's the exact same graph except shifted to the left 2 units. So For my horizontal shifts, remember these are exponents. X minus m translates the graph m units to the right because it always does the opposite because it's with the x. X plus m translates the graph m units to the left because it is with your x, so if it's a plus sign, it'll shift it to the left. If it's a minus sign, it'll shift it to the right because it's dealing with x. Because it's in the exponent with x, it'll do the opposite of what it says. Okay, turn the page. Let's look at vertical shifts. So if you look at the orange graph, this is the graph of 10 to the x. And now I'm going to graph the pink graph, which is 10 to the x plus 5. That plus 5 is not with the exponent. It is outside of the exponent, meaning it's not with the x. It's going to shift it either up or down because it's not with x, so it'll be shifting in the y direction now. Because it's not with x, if it has a plus 5, it'll be up 5, and I can see that this pink graph is indeed 5 units higher than my original orange graph. So once again, because it is not with the x, it'll be shifting in the y direction, which if you subtract a number, then it's going to go down. If you add a number, it's going to go up. Because it's not with the x, it'll be shifting in the y direction, and because it's not with the x, plus means up, minus means down. So let's take a look at what we've just summed up here. Here is my exponential basic form, a to the x, so there's my exponential, and now I have two shifts happening, x plus m and then plus n. Because this plus m is with the exponent, this will be shifting left or right, or essentially shifting along the x-axis. If it's a plus m, it'll be shifting to the left. If it's a minus m, it'll be shifting to the right. This n value, because it's not with the x in the exponent, this will be shifting up or down. Okay? If it's a plus n, it'll be shifting up. If it's a minus n, it will be shifting down. So once again, if the number being added or subtracted is with your x, it'll be shifting to the left if the number is positive. It'll be shifting to the right if the number is negative. If it's not with your x, it'll be shifting up if it's positive and down if it's negative. So let's look at some examples. My first example, a to the x plus 2 minus 4. This plus 2 in the exponent is with the x, which means it'll be shifting in the x direction, either left or right. Because it's positive, this will be shifting left 2 units. This minus 4, because it is not with the x, means it'll be shifting up or down. Minus 4 means down 4 units. So that's how you would shift that first graph. In my second example, I have 6 to the x minus 1 plus 3. This minus 1, because it's with the x, it does the opposite of what it says it's going to do. This is going to shift to the right 1 unit. The 3, because it's not with the x, it's going to shift along the y-axis, which is up 3 units. Finally, let's look at the last example. I have a plus 5. It's with my x in the exponent, which means it's going to shift in the x direction, opposite of what it says. That means to the left 5 units. This negative 3 is not with the exponent. That means it'll shift in the y direction, and it'll do what it says, down 3 units. So those are the basic transformations of the exponential graph. Now let's continue back to the lecture. It says equations with x and y interchanged are when x and y trade places. If x and y are trading places, it'll look something like this. So instead of the x being in the exponent, now my y is in the exponent. So essentially it's the exponential function, except now x and y have traded places. What happens when you do this is you are creating an inverse. And now you won't really cover inverses until 1050, but in order to understand logarithms, which is the next section, you have to understand that an inverse is created when x and y switch places. So if I graph x equals 2 to the y, so as you see it's the exponential with the x and the y trading places. If I graph that, I plug in different y values and solve for x. So here are my coordinate points. And you will see that when I graph that, I will get this graph right here in the pink. So for example, if I graph the point x equals 1, I'll get y equals 0, 1, 0. If I graph x equals 2, y equals 1, 2, 1. So I'm graphing this pink graph. That is the graph of x equals 2 to the y. Now the reason that's important is because as we notice, this is the basic exponential y equals 2 to the x right here. And now I have my x equals 2 to the y graph right here in pink. These are inverse graphs, inverse functions. There is a line here, this dotted orange line, it's y equals x. And that line, y equals x, means that if you have a graph reflected over it, then those two graphs must be inverses. It's a mirror image to this side and to that side, which means that when you switch the x and y, you're creating an inverse. These graphs are inverses because they are the same except reflected over the line y equals x. If you notice, instead of writing x equals a to the y, or in this case 2 to the y, x equals 2 to the y, instead of writing that, we see that it's notated as the log base 2 of x. That's because the log is the inverse of the exponential. The log is exactly equivalent to the graph of the interchanged exponential function. Okay?